Okay, so we have an example here of an insurance survey. And what we're trying to do is we're trying to work out if there's differing satisfaction levels for different types of college education. So let's actually just get the data in the format we want and the format we need for our input. Then we'll kind of go back over the hypothesis. So let's just kind of start by, the obvious thing would be to sort our data by the level of education. So just select in the top left, Control Shift, down arrow, right arrow. Oh, it's only a very smallish data set. And we want to do data sort, and we're just going to sort by the education level. Okay, and we've got college graduate, some college graduate degree, and some college. Now, obviously, this is an alphabetical sorting. It's not the sorting by the actual level of education. So let's just, we need the data in a slightly different format for this test. So go to college graduate into I, graduate degree into J, and some college into K. So just kind of copy and paste. Okay, so copy the satisfaction for college graduate. For graduate, just Control C and Control V for each of these, and some college. So there we go. We have all the details here, and let's just kind of calculate some averages here. So we have some intuition before we do the statistics. So let's select for this column, and let's go right. Okay, and let's just, because I like to be pedantic and I want everything on the same font, let's just do Arial 12. So we can see that the average satisfaction for graduate degree is 4.5. The average for college graduate is 3.4. And the average for some college is 3.14. Okay, so now our hypothesis is like, we're going to see whether or not these three things are actually equal. So let's just move up a little bit, and we'll take a kind of a snippet and we'll write out our hypotheses. Okay. So our hypothesis here is going to be, let's just kind of write it down. The null hypothesis is that all three means are going to be equal. Now we could write this as mu1 equals mu2 equals mu3. I mean, or alternatively, we could actually give it some meaningful significance. So because a mean college graduate equals mean graduate degree equals mean some college. And that's what I usually do, but I'll stick with the book. But the alternative hypothesis is at least one mean is different from the other. Note, this is not mu1 is not equal to mu2 is not equal to mu3. If, say, for example, mu1 and mu3 were equal, but we found that mu2 was greater, then we would still reject. If these guys were equal, but this one was greater than both, we would still reject, then we'd still reject H0. So we're trying to find evidence, and in this case, we're going to use, we're going to reject if our F statistic is greater than the critical value, or again, if our p-value is less than the alpha. Note, this is the same across all of our tests, which makes it a very consistent way of rejecting our null hypothesis. So let's kind of go back. Now we have the data in the correct format. And we're going to go to data analysis, and ANOVA single factor. So my input range is basically, we need to include all the rows. It doesn't matter if we have any uneven numbers of rows. Very important, we have labels in first rows collected. We're grouping by columns, i.e. each of my means is in a column, we could have done it in rows, but this is more normal. And we're selecting our alpha level, the type 1 error, the strictness of the test to be 0.05. And let's just select it to be output around, yeah, let's just give us a little bit more room. We'll do it in 01. Okay, so here's our results. And let's just make it a little bit more readable. I don't know why they chose like the palest font possible to show these results. So that looks a little bit things. So you see here were the values we kind of calculated before. We have the average for each of the groups. We've got the number of items in each group and the amount of variation. Again, in this class, if I teach this for my PhDs or even my undergrads, I build up this concept of ANOVA tables from first principles, and I spend a lot of time explaining what each of these are and having the students fill in the ANOVA tables. As this is a tiny bit of 1 week, you know, if I teach this as a stats class, I would teach 2 or 3 weeks just on ANOVA. But the two important values for us are these. And basically, actually, the three important values are these. And what we would do is we reject if my F is greater than my F crit. And this is also equivalent to saying reject if my P is less than my alpha. In this case, I'll put in brackets 0.05. So we can see here that if we're using the alpha equals 0.05, and again, if you go to the, as I said with the analysis toolpack, we could have done this with 0.01, and that would have made it a stricter test with a higher value of F crit. So reject if F is greater than F crit. Yes, F is greater than F crit. Reject if P is less than alpha. Yes, my P value is less than the alpha. So what we can do is we have, based on these two criteria, which are in fact identical, we're going to reject our null hypothesis. So let's go to my red pen. So we're going to basically reject H0. So there's evidence that at least one mean is different. Now, if I was to give my results to my boss in a real world business situation, my boss would probably go, I say, hey, well, at least one mean is different, but I don't know which mean. So my boss is going to say, you're an idiot. That's not telling me anything. So typically after you've done this test, then you would test the individual means. And generally what we do is we do the 2 sample t-tests we just did before, but because we're doing multiple t-tests, we actually make the alpha much lower. We make the tests much stricter. One rule of thumb is, say for example here we can compare college degrees and graduate degrees, college degrees and some college, graduate degrees and some college. We have 3 different comparisons. If we rejected the null hypothesis, then we do 2 sample t-tests, and we do something called a Bonferroni adjustment, where we do the alpha t-sample t-test with our standard alpha divided by, in this case, 3, which has our number of comparisons. But none of that is in this course, so I don't want to confuse things further. So at the moment, I'll just have to be with my boss thinking I'm a bit of an idiot. It's not a new thing. And we reject the null hypothesis and say, yes, at least one of these means is different.